It is Lazy Mama here. Today we're going to be doing step assignment 9. And so without further ado, let us begin. So, the warm-up. Isosceles triangle ABC, lovely. Isosceles, we love isosceles. ABC has AB equals BC, which we know. And there's a line drawing B to the midpoint M of AC. I considering congruent in reference to the Despicable Me. Show that this line is perpendicular to AC, and that bisects the angle at B, and that BAC, being this angle, is equals to BCA, which is this angle. So we are going to need a bigger diagram for first. So let's draw some A, some B, some C. From the start, I already realized I drew it wrong because this is the isosceles. So we draw a line here. And so we can say this is some x, this is some x. This entire thing is y. Actually, no, we'll say it's 2y. The entire thing is 2y. And so each of these is y. And so therefore, first we need to show that this line is perpendicular to AC. So we need to show that this is 90 degrees. We know that these two are the same angle. I forgot how you draw the same angle, but like, you know these two are the same angle, which is draw theta, yes. So according to the cosine rule, if you plug in the cosine rule for AB, theta, and AM, since we know that this is M, it's the same result. We can just say this is the same point, can't we? We can just say this is the... We need to show that this line is perpendicular. How do you do that? Yeah. What if we genuinely cosine rule it? Like, what if we just write z y plus and minus 2zy cosine this mysterious angle, which we'll call alpha because we love random variable names. It does not help. I feel like we need to use the fact that it's the midpoint, specifically the midpoint. Okay, maybe we figure out if it bisects B. Maybe that's easier. Not really, no, because that follows directly from the fact that it's perpendicular, isn't it? Oh wait, it's asked us to consider congruent triangles. So actually, we don't know that these are perpendicular yet. Wait, this is the same. So A, B, M, and B are congruent due to SSS. Um, 9 plus 180. Okay, so and here. Okay, right. I forgot. We're supposed to talk a little more, even though I probably won't be doing that much talking for the later TMUA that we're doing. Oh, something horrible just happened. Oh, good enough. Did my OBS get messed up? Yeah, like totally did. Okay. Wait, why is it showing the music that I've got playing in the background? Hide that for obvious reasons. Okay, so let's continue. So bisects the angle at B. Again, because it is congruent, we know that A and B equals to no, equals to MCB. So therefore, B. Six B. And finally, BAC equals, well, that's obviously just congruent. I'm not going to bother, it's just congruent. Or even sum of, uh, you know, sum of angle triangle equal 180. That's also valid. So yeah, that's that. We're moving on to II. Oh lord, more triangles. Okay, so triangle ABC, side length BC equals A, CA equals B, and the other one is C. Given that the triangle can be expressed by okay. So actually we gotta redraw this. But base being AC, B, this is B, this is A, this is C. Okay, so that's our diagram, but there's also another diagram we could potentially draw, which is this. Sometimes there are problems that result from edge cases like these, so we'll just write that down in the background. So it's the base times the height, which we well know to be pi fag. Oh, times a half. Now we've got this. An area of a triangle equals this. Actually, I'll remove the x, because sometimes I use x as my variable and it's not convenient. So our next step is need to show it equals b a sine. So what's sine? Sine c is equals to a divided by a divided by b. No, this could be a. Let's just write a. Actually, we don't know what's half. Okay, wait. Let's start from the beginning. So we know that some k. Let's assume this is k. This is 1 minus kb. Some kb squared, the square root. Kb squared. Now this equals to the straight line here. The straight line that splits the triangle in half. This is also equal to 1 minus k b squared a. This. So now we can start doing the math. Which means that a, c, and those two take each other out. I mean, the k squared and the b squared take each other out, and so now we're left with this, which assuredly is not that wonderful. So now we can show that this is BA sine C. First, we need to define what sine C is. A is dividing it, of course. Then you got the opposite. which I guess is one of Z. I would just call it Z. Z. Got the area, which is B, just B, multiplied by A, multiplying by Z. So we know that Z also equals conveniently to A sine C. So therefore, it's just equal to ABC. Yay, we did it. So now we can show also that the area equals BC sine. Shouldn't be that hard. Oh wait, no, I've done it. Okay. Okay. So, now we also need to show that area equals half of VC sine A. The way that this can be done is essentially the same method. So sine A this time. Oh, sine A we know to be Z divided by C. And so again, sine AC Z. So 1 Z C C B Z equals to 1 BC sine A equals the area. And then we can use this to deduce the sine rule. Wonderful. And we also need to consider this edge case. Even more wonderful. Okay, so exhausting does sound considering this edge case. So let's just show that the sine rule exists first. Realize that this will be useful to me. Substantially more so than wasting my time on this. So, by multiplying everything by ABC, we get this, which sounds suspiciously similar to this. And we know this is the area. And we know that all three of these are equivalent to each other. These are equal to A. After, just in case I forget, multiply by A, B, C. And okay, so now we're forced to consider the edge case because they haven't really given us much room to work with here. Uh, you know, I've got this question, I guess, that I could answer, but I just be putting it off. So let's get. So this is our height. This is some K. Now we know that A squared equals A squared plus K squared. We also know that C squared equals B plus K squared plus A squared. I think we can get away with just proving the area rule, right? That is equal to half H B plus K. Sine of this mass is this. which doesn't, okay, sine here doesn't mean anything. Sine here could. Yeah, sine here could be useful. Oh, I see the trick. So, what we actually want to write here is sine 180 minus c, which this being c, this is 180 minus c, right? But this is also equal to sine c because of how trigonometry works. Because if you consider this graph, which is the sine graph, this bit is equivalent to this bit. And you can get 180 minus c equals c for the sine function. So that means it's sine c. That happens to be, sorry, that happens to be 5 by a h. That is sine c. Wonderful. So now we can replace h with a sine c. Oh wait, this is just b. So now it becomes ab sine c equals the area. Okay, restoring our audio now. Let's see. I'm not very good at graphing trig graphs, so let me just pop this in just to make sure I did this right. And no, I'm not. So, what went wrong? Wait, is this? Oh, I see the problem. This is in. Okay. Hmm. Oh, hero. This is the normal trig graph. You reversed it. But they're clearly all moving left. Which means I did something wrong here. Yeah, okay, my poor understanding of transformations is coming back to bite me in the ass. Well, hey, it is possible to do something. Oh, no, it just goes and fucks off wherever it wants. Wait, I can make a slider. I forgot about those. See? That one is slider. Okay, that is slider. Which order of steps to do? Aha, so I was right. For example, let's take 1, right? Like maybe let's take 4. So if you want to do -8, or you're dividing the son of a bitch. Okay. Yeah, no, that's right. So what went wrong? And you add 90 degrees, half a pi, make it like this. That looks completely like this. So I did get it right. Yeah, okay, so I do understand how to do this. By the way, this is fine. But looking back on the original question, what the fuck? Oh, I get it. You're supposed to divide this by 2 because it's split into 2 angles. Because there's like 180, 180 minus 2 alpha is actually equals to this plus this. So you're supposed to do it in 2. So that means this is in fact 2 sine, cosine, cosine. I'm a dumbass. Oh, fuck. Okay. Oh. Right, okay, so let's continue. I guess we're developing like endurance, huh? I consider in the shape of the motherfucking graph. This is the answer. Alright, I must read. I probably should swear that much. Bro, I probably shouldn't swear that much. Yeah, there you go. That's how you speak English. Can do that. Find where the graph intercepts the y-axis. The y-coordinates of the turning graph. Plug in 2. Negative 15. Plug in -2. Guess 17. E. How many roots? There are 3. I. Sketch the graph of each of the following cubics. There's 6 of them. What the hell? Do not attempt to find the intercepts with the y-axis, with the x-axis. Do not use a graphical calculator. Do not plot points other than the turning points and the y-intercept, which I would hope, yeah. Okay, so this promises to be laborious and somewhat boring, which is good for me because I'm really sleepy right now and I don't think I can handle something harder. There's a double root. Wait, you just want the y-intercept? That's crazy. Oh, so you just want me to differentiate it? That's really odd. Sure, but you understand this is a giant waste of time, right? Watch me make like 5 different mistakes here. Okay, so wait, x is okay. Here we go. So what? Oh wait, no, x is one of our turning points. And -2 is also a turning point. So this is a turning point. Other turning point happens to be here in so y equals 5 for -2. So it's somewhere here. It looks like this. That's numero uno. Differentiating again. Wow, so exciting. It's the exact same? You're kidding me. They changed one number. Oh my days. Is TSS? Wait, I fucked it up. This is -3. So -2 is 16 plus 4 minus 3, so that's 5. 2, 5. 5 goes here. You go here. I feel like they're mocking me somehow. Like, I feel like there's some kind of easier way to do this. Is there? Okay, maybe you can do it without differentiating, especially for C. I can see it. I can see how you do without C. Without for C. So our turning point gonna be 0 and this. With sheer power of inspection, I think. Just in case we'll differentiate it. Because I don't trust myself. I trust myself not to clown on myself. Aha, knew it. I did it wrong. Yeah, okay. I forgot that the coefficient also changes. So oops, this is actually -1. Yeah, x equals 0. It's -3. Again, why do I keep running on this line? -1. Plug not -1 in. Isn't this really exciting? I'm actually neurotically sleepy right now. I'm just hitting. Okay, so this is 4, this is here. Probably looks something like this. Ignore that. That, yeah, okay. You know what? I'm skipping this. Like, actively, this is not worth my time, gang. Genuinely, I don't care about drawing 6 more cubics. Following. I know how to draw a cubic. Fuck off. Right. Let's go do the step question. Skip. This down. Sketch the curve. First in the case. So, for one of these, like this. One of these, actually, the other one is going to be negative. You need to plug this in. Y equals this. Negative, of course. Must be. There we go. That's our lovely graph. Sketch another graph where a is smaller than 0. Basically, same outcomes. This time, let's slide really far though. Okay, so you still need a negative in order to make the thing um, balance itself out because 3x plus 2a if a is negative, so let's say it's negative 2, then it becomes this, right? So 3x. So you shove a in here. Let's say you shove um like any negative number, basically, then it would just exacerbate the problem, make it even more negative. So we've got to also negative the root that we put here. Like that. And then we also just plug in the answer. Oh, great. Yes, like this. Sure, good enough. Show that the equation has three distinct roots. That's why you were asking us to figure out the roots. Ah, whatever. We'll just figure it out. Wait, is this on the positive side or the negative side? Like the positive x or negative x? Great question. Right. So I missed out on the fact that this was negative. Oops. I mean, we can be pretty sure that this is negative, right? Wait, what am I doing? This is the wrong graph. God, sleep deprivation is not fun. Okay, so we know for sure if A is negative, then this is positive. This is positive. This is positive also. So that means that you go somewhere here. I guess because for the plot, you're gonna have to be negative. Although I will do a bit of experimenting, of course. Let's see. If this is positive, then this is negative. This is positive. This is positive. So we have no fucking clue. It's essentially the conclusion that they've given us. But we have no fucking clue. It could be negative. It could be positive. It could be negative. It could be positive. Uh, I'll just say it's negative. Why not? That's not one. Yes. That doesn't work, does it? You notice this now that I think about it. Actually, yeah, wait, this is guaranteed to be above. So if it look like this. Okay. Breathe. You can practice. You- Oh Lord. My computer reflects my mental state. Not good. This is impossible to have two turning points that were situated like this. By necessity, it has to go like this. Okay. Guess I'll write the same thing. You can only have three distinct roots if, only if, first one, these are 0, right? And also if, then it stays above. So the second turning point stays above. Wow, I really hope I don't show up sleepy to my Cambridge interview. I'm bombing this. Yeah, I guessed it was something. I think I had a good 27 B plus 4. Ooh, hey, hello, Mr. Minster. How you doing? Sweating on drugs, eh? Drugs are bad. Holy shit. What's going on? That's not up to me. What the fuck? That's what I asked before. No, they all had the thing above. Because this is negative, so over here now. Yay. Mm, you got that. You have to make negative. That's weird. Otherwise, I have a few cases. I'm not doing that. I'll kill myself if I fucking geometry. Just go to sleep. Oh my days. Hmm. You know what? No, I'm gonna push through this. I believe in myself. I just need to figure out how to reconcile the inequalities. And then we can move on to the warm up. We can get the warm up done, check our answers, move on to the next one. We always have. The way of hard workers. Wait, I get it. Because B we know is negative. If you multiply it, come on, we stop lagging. Mi computador explosed. Good man, you don't look good. Oh no, you don't look good at all. Okay, so I might have to end the stream here, not because I'm tired or anything, even though I am, but just because this does appear to be broken. Bye. Wait, is it working now? Oh, it's working now. Only barely, Jesus. Alright. Is this why people have PCs so that they can run fucking OneNote and OBS at the same time? I mean, it's big cognitive load for a computer from the 1900s. Right. This is outrageous, but whatever. Okay, so continuing. So if we multiply the two, since we know that one of them is negative and one of them is positive, the entire thing will simply be smaller than zero. And this probably applies for this one. Yeah, it basically applies the same. These are the same. So yeah. All right, let's go do the warm down. I'm desperate to be warmed down. I am. I've begun thinking we should probably do the intentioned exercise of checking our answers on screen because otherwise I have to do a late night and check off my answers all at once, and then that's why I'm tired right now. So AB equals BC. Yeah, some sleaze. Lines A, BA, BC extended by equal lengths, DE, respectively. Task is to show that the angles BAC and BCA, the base angles, are quite equal. And I've done it wrong again. You can only use congruence established with SAS, and the fact that angles in the triangle are supplementary is sum to 180. So that BCD being this, and BAE, oh my bad, I drew it wrong again. Okay, let's wake up, first of all, clean this up, lay my computer down flat, and take this seriously. So let's just draw exactly as they've done it in the diagram that they've already provided us with. You got AC, you got DE, you got B. Now you need to show that these and these are equal. You can only use congruence established with SAS. Already established. These two are equivalent. And the fact that angles in a triangle are supplementary. So, so we know that these are equal lengths, which is great for us. So now we know that BCD is congruent with BED. Why? Because uh, BD equals BE. B same angle. And of course, BA equals BC, which was provided to us. So now we know they're congruent. And we know that the angles are supplementary. But that's not important because since congruent, BCD equals BAE. No further calculations needed. We just know it. DCA being now this, and EAC being also this, or equal with each other. Ah, okay, so okay, wait, okay, so let's narrate this. Okay, so the first thing that we might notice is that this is a straight line. This is a straight line. So that means line on line sum angle line equals 180. Therefore, we can figure out that ADE actually finally equals to DCE. Oh, sorry, this is DAE. Yeah, because 180 minus DAE equals 180 minus BCD. Let's mark equal angles with some kind of different color, like gold. Gold is a lovely color. At least the confirmed ones. Let's mark as gold. And we also know that these two are equal to each other, do we? No, we don't. That actually comes later. It'd be easy enough to prove congruence, but the thing is, you need to prove congruence using SAS only. That really does not give us many options. Okay, so I've been thinking for a while, and I'm still no closer to figuring out how what we need to find out is How is CAD equals to A C? Yeah, so how is CAD equal to ACE? If we can figure that out, we can prove the congruency of ACD. So this triangle and this triangle. Again, limited twos. You can't exactly prove something is congruent to it with itself. So I suppose we could try and work out if this is congruent with this, but I don't see how that help. And I don't see how that would be possible. I'm not even sure if the line thing is possible. If the line thing isn't, then we go back to square one. We have made no progress, basically. Maybe it has to do with 180. How could we do something with 180 here? 180 is interesting. We know that 180 equals DCA plus AC. Now, does that take us any further? No, not really, but it's a start. Behold a triangle. Anyways, um, DCA, EAC, DCA, EAC, DCA. Wasn't AC? Yeah. DCA, AAC. Honestly, I'm bashing myself into a wall. I don't. Okay, give me a second. Let me just take a break for a while. Okay, I'll be back sometime. Don't know. Oh, wait, I've been muted this entire time. Huh. Oopsie. Oopsie poopsie. So, anyways. Surely this is just duh material. Like, how could that not be true? Sunyan. Okay, let's ignore the upper bit. The upper bit probably isn't relevant. So let's just focus on this. Like, this, the thing is, we don't know this. We don't know that it bisects that particular bit. Like, you know it just from looking at it, but unfortunately, in this day and age, it's not quite good enough. Okay, I'm gonna guess, right, that ACE equals 180 equals our desired angle, BAC, plus some x. But we don't know if these two are equivalent. Oh my days. Okay, we're taking the break 3 minutes early. I'm really sleepy. I got like 4 hours of sleep last night, so I'm just gonna go to sleep.